Welcome everybody to Dallas Personal Robotics Group for Tuesday, April 14th, 2026. It's Robot Builders Night Virtual. We'll do our normal roundtable presentations and then open it up for any questions or comments. So tonight, for housekeeping, I have our regular club competition announcement. DPRG is hosting Roborama 2026. Going to take place at the Dallas Makerspace on Saturday, May 23rd. Events include quick trip, line following advanced, barrel racing, 6-can, 4-square, and sumo. Bring your robot. Should be lots of fun. If you don't have a robot, just come on out and attend. It should be a good day. And Mark will give us an update on the competition he was just at on the weekend.
Yeah, it was a great event actually. It was their first time running it, and it had a pretty good turnout. We had a great turnout from DPRG. So Ray was there, Mike was there, Mark D, Trish, Paul, and of course myself and Doug. So it was a really good turnout, and we had a lot of fun. There was some interesting little bots. There was one other large bot like ours with a parade. I do have a little video of it, so I can show it off. If I can get it to work, share. Hopefully this will work. You'll see that, okay? Okay. But yeah, this was one of the actual organizers that made this. He made a little, and it really is an animatronic, mechatronic display with cams and whatnot. A little park scene. You'll see that, okay?
Yep.
It is really, really fun little bot that he had made. There were some issues with it when it ran around the track. It was like it was in an earthquake. It kept bouncing. The weight was all off on it, so it was just like bunny hopping the entire time around. It was really fun to watch. But it was great. It did a really good job. But yeah, so we took ours, of course, and it worked 99% of the time. The line follower bot did stop after a little bit. I still need to see why. I've got to break it open to check on why it's not working now, but it's probably the motor. But yeah, it was a really good event, really good outreach. Mark, the guy that was organizing it, is going to sign up as well, so a new member for DPRG, yay. And then, of course, they invited us back next year, so we're going to keep in touch. They might even come out to the Roborama. So yeah, it's good. Made some friends. It was a good day.
Mark, how many line followers were there in the competition?
The big ones, just the two of us. But there were a lot of smaller ones as well. And there were some kind of sumo bots, very radio controlled sumo bots, kind of. I don't know if they were Vex or Lego. Do you know what they were, Mike? Ray? They were kind of like Vex-ish.
No, but they were just little demos for the
for the kids,
3-year-olds. Yeah,
yeah, they're fun. They're fun to watch.
Yeah.
It was catered as well, so we all had sandwiches, and yeah, it's just nice meeting new people.
Yeah, because like some of the students, they said, "Oh, we started 3 days ago and just didn't, and we couldn't finish it." So, and Mark says, "Oh, we've been working on it for 3 weeks."
Yeah. Yep. Yeah, it was a lot of fun.
So that's a college supported club, or just they meet at the college and no association?
I think they were facilitators with the college, so yeah, it was from the college. Yeah.
Yeah, no college guys participated. So
That's surprising.
Yeah,
but it's their first one, so
yeah. I mean, we had some high school try to do it, but yeah.
Yep.
It's good.
Right.
Thanks, Mark.
Thank you.
Up next, we have our first presenter, Tom.
Okay. This is the real robot, just so you can see it here. It's showing it live on my desktop is very uninteresting, partly because it's very small here, and partly because it slides all around the desktop. I tried rubber feed on the bottom, which promptly fell off, and a few other things. But I'll show you a video showing it running on a rug upstairs later on, just so you know that it actually runs. I'm going to share my screen here, if I may.
I still think hot glue feet are the way to go, Tom.
And I was thinking I should do that. You had mentioned that with yours, I think, Mark, that you'd used some hot melt glue.
Yeah.
Just
Something
go
like
for
that.
a shag desktop.
Yeah.
Say that again.
A shag desktop.
I was tempted to go look around my workshop for some scraps of rug. It was simpler to just take it upstairs. So I'm not sure what you're seeing.
Yep, we see the bot and the controller.
Okay, you see my mouse moving around.
Uh-huh.
Okay, so that's the first view of the thing. There's another little angle showing the lovely fingerprints all over my tablet, I thought. But it gives you a different perspective on the robot. This is a closer view of the controller. And Mark, you'll note that this is showing access to the Sesame controller beta server. This is the private server that the ESP32 creates and emits. Was that the same one you were using when you controlled yours?
I'd have to check.
Okay, I have some comments about that a little bit later that I thought would be relevant. Before I show you the video, though, I had an interesting time calibrating the system. First of all, I did not use the battery design that came with this thing. It was a couple of AAA lithium ions and a voltage regulator. And instead, I put together 4 AA size nickel metal hydrides, which you can see here duct taped to a plastic panel, which is then screwed to the bottom of the robot where the original battery compartment would have been. This worked out very, very well and eliminated the need for a voltage regulator, and presumably would give a much longer runtime, although I haven't had to worry about runtimes. As I mentioned, I changed the power. I had an interesting time with the servo calibrations. My impression was that I should probably try to get them reasonably accurate. The test utility for testing the servo motors that's provided as part of this project online isn't particularly useful, so I wrote my own, which allowed me to get at each of the servos individually and essentially determine the microsecond to degree relationship for each of the servos, as well as figuring out the best position to place the servo arms on the servo output shafts, which is non-trivial given that the servo output shafts only have about 20 or 21 positions available around 360 degrees. So you want to try and pick a reasonable position to place the servo arm on the servo output shaft, and then adjust the microsecond values for the 0 degree and 180 degree points, which is what the software, I eventually determined, is what the software wanted you to do. The software assumes that all the servos are identical. They are not. And that all the servo mounting points would be identical, and they are not. And I discovered that in the course of performing the calibration with the additional software I wrote to make it easier to do. I then had to figure out how to use the calibration information that I had obtained using a very sophisticated tool from my toolbox, if you can see that. There's an old elementary school program. Very handy for calibrating servos and servo arms. There's a kind of an implication in the code that I was reading and in the library that you're looking for min and max pulse widths, which initially sounded like they were intended to provide knowledge of where the servo's physical or mechanical limits are. In fact, that's not true. What you're looking for is the value at the 0 degree point and the value at the 180 degree point for the servo arm. That's not made very clear, so I thought I would mention that here. But it turns out the problem is more interesting. Even after I did that, I could not get the servo arms to do what I wanted them to do. And it turns out that inside the servo library, which is used by this particular project, there's some additional parameters that need to be adjusted. And the first is there really are values in there for trying to prevent the servo from hitting its mechanical limits. They're hard-coded inside the driver, inside the library. So you need to go and find them and fix them if you have a problem with them. And I had a problem with them. I also determined and confirmed that the values I was supposed to find in order to put into the mainline code are in fact the 0 degree and 180 degree points. There are default values provided within the driver, and those default values are nowhere near the right ones for the particular servos I had. And in fact, the range that the library was providing did not provide enough range for some of my servos. What I've done is I've just simply placed here the values that were in the library, 500 microseconds and 2500 for the outer hard, what I call the hard limits, and the default limits of 400 and 2400, which it turns out you can override. The person who originally wrote this servo driver package clearly had tested it on other servos, because inside of the driver code, you find commented out sections for several different servos. None of them worked for mine, but I was able to understand fairly easily what I had to do to make this thing work. There's also servo limits in the main code, which were initially defined as 732 and 2929 microseconds, which I thought was interesting because it's quite a ways away from what I ended up needing for each of my 8 servos. You can see the min and max pulse width arrays that I ended up using down here. When I put those in place, after I had decided mechanically where the servo arms should go, I ended up getting the robot's various joints to go within a degree or two of where I wanted them to go. So I think the effort was worth it, but I was just a little surprised I had to figure out how to go through all of that. But it was worth it. Mark, did you have problems with calibration?
So I got a mouthful of chips and salsa. Honestly, I haven't calibrated it.
Okay. So
Or
it
literally
didn't make
went-
any difference, maybe. Maybe
I
maybe
literally
I'm
went
just a
plug
little
and
too
play.
paranoid.
But I like this. I'm gonna look into this.
Yeah. When it turns out that the number of positions on the servos is either 20 or 21, depending what results you look at online. So that means that that where you put the servo arm relative to the servo output shaft is very, very coarse. 16, 17, 18 degrees resolution in terms of those positioning. And you're kind of stuck because the servo arm is bolted into the leg, and then you got to put it on the servo, which means you want to make sure you get the servo in a reasonable position without hitting its end stops. So it was kind of an intriguing problem, trying to get this thing to work the way I wanted it to. But it worked eventually, and it was an interesting exercise.
So your min and max is probably, the variations probably due more to the limited number of positions that you can put the arm on the servo shaft.
Certainly that's a major parameter in limiting what you can do. I should also mention that there's once you're forced to read through the mainline code, then you run into another generally undocumented capability of the mainline code, which is what are called sub-trims. Mark, did you run into the sub-trim function?
Nope.
Okay, well, after reading through it and trying to figure out what it was for, I think it was probably a kind of a crude workaround to solving this exact problem of the mechanical coarseness of resolution of mounting. I never used it. I left it at the sub-trims all at their default value of 0. And there is an array of them. There are 8 of them. And there's a kind of a crude method of attempting to provide the values, but it's not documented. It doesn't look like it's complete. So I think it was probably a workaround to solve a problem that somebody came up with when they realized they couldn't get the legs to go where they wanted them to go. I never used it. I used this method instead, which I was comfortable doing. So the sub-trim stuff is also interesting to look at. You could add it through the USB serial port, which I never got working, incidentally.
I was kind of curious. Did you, okay, you established what your endpoint should be for 0 degrees, 180 degrees. Do you think it's linear? between that, or
It is not linear.
not linear,
Oh.
not very non-linear, or
Not very, no. And it's different from servo to servo because
Yeah.
these are dirt cheap servos. The little resistive analog potentiometers they have buried inside them for feedback probably are not particularly linear.
The digital
if you buy a-
servos are way better.
If you buy a
that.
$20 servo, they work a lot better. Or as you say, there are very sophisticated digital servos available now, but you pay more for them. I'm cheap, and I had these in my box. So they work, but I do know they are non-linear when you buy them this cheap. Okay, now, of course, the grand presentation here.
it's an alien.
There he goes.
It's alive. Just give us some AI now. Yeah.
It is definitely a very cute. I don't think I have any more here. It's a very cute little toy. It would be interesting to consider what it would take to put some form of distance measurement, crude though it may be, and perhaps some form of IMU, so you can tell whether it's going in a straight line or not. But my God, the filtering required for IMU signals, given the mildly random variations in direction, even when it thinks it's going straight, might be a real nuisance value. The software uses about 75% of the available code and RAM space. So there's a bit of room for messing around, but not much.
Lulu makes an optical flow sensor
Okay.
that you would probably be able to use on it. It's not that cheap, but I believe it would do essentially reports back like a mouse.
Okay. Yeah.
To give you, how far you've moved in whatever direction. That may be an option to give you, good feedback on where you are, how far you've gone.
I don't know if that's designed to handle where it's bouncing up and down that much.
Yeah, I think the whatever sensor mechanism we were to try to apply to this thing might be very complex. So maybe if you watch it with an overhead camera, you might get a better feeling for where it's going. I don't know. I wanted to make one more comment, and that is the ESP32, of course, its Wi-Fi is only 2.4 gigahertz. Most of the smarter devices in my household immediately switched to the 5 gig bands in my local area network, which meant that it was interesting that my relatively new smartphone would not connect. It just refused to attempt to connect to the robot. The browser on my desktop, which is hardwired, had no problems connecting. It could care less, of course, what the Wi-Fi looked like. But my new smartphone would not connect. This really, really old tablet had no problems connecting because I think it runs on 2.4 gig. But that may also be something to consider when you're working with ESP32 class embedded devices with Wi-Fi. Other than that, I thought it was a fabulous design. This kid who put this thing together, Dorian, really, really did a good job, in my opinion, especially since I think he's still a high school kid. So, super work.
He did. I agree.
Huh. So on your new phone, is there an option to set which Wi-Fi band it's using?
Yeah, I looked into that, and no, there isn't.
Oh wow.
When I tried to research how to do that, the advice that I got was, no, there's no device, but you can force it because the 5 gig range is much shorter than the 2.4 gig range. So they said, simply walk your phone out of the 5 gig range and it'll switch to 2.4 gig.
Oh my God.
That was the advice I got.
That is horrible.
Yep. It also said there are ways to shut down the 5 gig bands in your router. Well, of course there are, that's not the point. Yes. So that was a mild surprise, but I have enough devices floating around that I probably figured out what it was pretty quick.
Did you try connecting over Wi-Fi direct?
I did not. I'm not sure what I would have to do to try that. Do you think the ESP32 mechanism is programmed to support that?
That's a good question. It may not. Well, it
Yes,
probably
32
does.
has access point mode.
Yes,
Yeah,
it is in
yeah.
access point mode.
So that you just create its own access point, and then you connect to it with your phone.
And yeah, and that's how I ended up connecting to it on 3.2 gig, or on 2.4 gig. But you got to kind of know to look in that band for it. The other thing
Then
that
it should show up as a discrete network on your phone, and you can just select that network.
and that may have been possible, but it's something I don't know that much about. When I connected to it with this old tablet, I found the separate network that the ESP32 had indicated. I had to log into it on the tablet, and I logged into it. And as soon as I logged into it and went back to the browser, it immediately found it. So it was easy. I don't know what I would have to do to try to do the same thing with my new phone. And I had a solution, so I wasn't going to look for another one.
Sure.
It was a good toy. I don't know what I'll do with it now, other than put it on the shelf and bring it out at parties.
Hey, horse.
I put a link in the chat for the optical flow sensor, Tom.
Okay, thank you. I'm going to find out where I exit. Stop presenting right here, it looks like. There, how's that? Okay. That's a fun project. I enjoyed it. Took a little longer than I thought, but it worked out well. I had some mechanical issues to deal with my 3D printed parts. They are really, really tight at the point where the hip joints come up against the upper section, the upper structure. So I had a little bit of interference there. I had to file away. That was easy.
Is that a star? Is that a gold star or a black star?
Oh, yeah, it's a gold one.
Star.
Gold star for Tom.
Yay, thank you.
A walking, smiling bot.
It bows and waves.
There you go, our first gold star of the night.
Yay. Good job, Tom.
Up next, I believe we have Ray.
Me?
I thought, did you not say you had something, Ray?
No.
Mike. Yeah.
Nope.
Well, then it's Mike. I thought I had Ray in here for some reason.
Nope. Shouldn't have.
Yeah. So last week I showed my my barrel racing, going really slow around the barrels, and today or this week I made it run faster. It took, I had to add code in there to scale the angular velocity with the linear velocity. Like what I do is I say run at this linear velocity, and then it'll calculate what the angular velocity should be to go around the corner, around the cans and stuff. But what I found was it overshoots, and well, basically it says, okay, like when I go around a can, I want to come out at a certain angle so I can see the next can, the next barrel. And what happens when because of lag in the Ross and the sensor lag, it'll go, it'll think it's at a certain angle, but it's actually overshot it by 10 or 15, 20 degrees or so when I run it fast. When I was running it at 0.1 meters per second, it was great. I sped it up to 0.2, it was okay. 0.25, it doesn't see the next barrel anymore. So I'm going to sort of show my overshoot problem. and I've been, like today I said, okay, I'm going to start working on the lag issue. So I wanted to measure get the lag in the system. So I was noticing that I didn't add any timestamps in my messages, my topics. Basically, when it first comes into Ross, it gets timestamped, supposedly, and then every time you modify it and create a new topic, I didn't add a timestamp into it. I used another timestamp, and then there's two timestamps that you can use. One is system time and one is Ross time. And I noticed that I was just using which one. I wasn't being very consistent. So I was going through making sure all the timestamps are done and trying to add timestamps to the topic messages. And yeah, it was, oh well, but I finally got it to work right before here. And so I'm going to use my controller, and you'll notice that it goes around the first can and then it doesn't see the second can and just runs into the wall. So
what are you using to see the cans? Is it a camera?
Camera, yeah. Or no.
LiDAR?
Oh, I do LiDAR and camera, but to exit the first barrel, I do odometry. I know what the angle is, and it seems to be overshooting on that. But yeah, so bunch of stuff. Let me see, where is my? Oh, there it is. So this is the over here. This is the first can. That's the robot, and it's supposed to point to that can, the second can. So I'm going to press this, and you'll see what happens.
Yeah, I know on like the OpenMV H7 cameras, if you scan too fast or rotate too fast, it has a harder time seeing cans versus like a slower rotation.
So you can see it's not going to think. Oh wow! Oh,
It really liked that can.
It wasn't happy, so I got to stop it. Stop! I have timeouts, but my timeouts are. I thought I was scaling them right with the velocities, but it's not. Stop! Stop! Okay, finally stopped. Oof. Oh, well. That's my demo.
Do I call that significant progress? Is that a black star? Is that a gold star?
It's a star of some sort. So this is my robot, and yeah. So the camera is there, and the LiDAR is here. So oh well, that's what's going on.
You muted, Paul.
I give him a gold star. It ran autonomously. It did its best. I would still say it's a plus. It found the first can. It wrapped around that can, I think, fairly well.
Yeah,
knock it over.
Yeah, it has potential.
Oh, it really kept its distance to the can. It looked to me fairly consistent all the way around it.
Yeah, it uses the LiDAR to measure the distance to the can and hug it when it goes around.
Yeah, it seemed to be, you look to be about, I don't know, 3 inches away from the can, and it seemed to hug it all the way around.
Yeah. So I just got to fix the release angles and stuff so that it sees the second can.
Yeah, I thought it did well. It come out of it. It was on track to aim to go counterclock or to go clockwise around the second can.
Yeah, but it wasn't. But it couldn't see the can.
Halfway. It lost interest.
But it was pointing. The can wasn't in the field of view of the camera. And then something distracted it. Yeah. Yeah.
I just updated the camera on mine for, I had a 55-degree field of view, and it was pretty narrow. And I bought another one, and it's 110-degree field of view.
Oh, is that just a different lens or what?
I bought a whole new camera module. It's a different camera module, but it's the same thing. A $20 USB camera. Just to be able to do that.
Let's see if you can see. Yep.
Yeah. Okay. So I should be able to fix this real soon. So next week.
Good update, Mike. Thank you.
Mm-hmm.
So that was the end of our presenters for the night.
All right. I will say, talking about next week, we have the monthly meeting we are in the interactive room, so we can set up some tracks if we need to set up a test run for next month.
I'd like that. Yeah.
Mhm.
I probably need to do that for sure. Check things out.
That would be a good trial for everybody to set up some lighting parameters if they're using cameras. And
And we do have a tech talk as well, so we'll do that first, and then we'll break out the fun stuff. Well, the other fun stuff.
What's the
did you
talk?
put a posting out on the Tech Talk?
I think Paul did. He
I
disappeared.
don't remember seeing one.
I believe. Oh God.
You're
Can't hear you,
muted, Paul.
Well, there's
Yeah, I think it's a big time tech talk.
Is it the Sensori one?
Yeah, Ross Melbourne from Sensori, who the folks who've been selling the robot mowers, is going to bring along his Uni Tree go-to robot dog and demo it, and may also bring a humanoid of some form, possibly just a torso. Unclear if that'll happen, but that's a big deal.
that's at DMS.
Mm-hmm.
Oh, I'll book tickets. I'll fly out.
Come on. Let me know. I won't ship you a t-shirt. I'll just hold on to it.
Yeah. You can stay at my place, Pat.
So what do you mean just a torso? What, just legs?
No.
I think the torso might be mounted on wheels, is what he said. But
Oh.
but the and I'm not sure if that's even going to happen. But the dog definitely will. And when I went round to their office couple 3 months ago, one of their interns was demoing the dog to me, and it was really cool. It was the form of the Uni Tree dog that has wheels on its feet, and so it put his
That
foot
one's
down,
great.
put the
Yeah.
paws down, stood up and did a handstand on its forefeet, rolled around a little bit on its forefeet, did some bounces on its forefeet, and then it was just stupendous. So it's going to be a very cool demo, I believe.
So are those still like in under the $10,000 range, or what are they? Do you know?
Don't know.
That's their higher end quadruped, if it has wheels on it. So I don't remember the price, but it's not like their little one, which was approaching like the sub 2,000 range, but I don't know what their current price is.
This one's above 10. I see like 13, 14.
Yeah. Yeah,
Wow.
that's an amazing robot. You see some of their videos where it's like just tooling down the side of a slope and things like that, running through water, and it's jumping around on things. It's pretty amazing. I think that's the outdoor format of the future.
That's cool.
Yeah, so that'll be a meeting to attend in person, so you can, if you possibly can. But obviously it'll be we'll
Is
do
that
that
this weekend?
Next weekend, 25,
25th, I believe.
next weekend, right? The 25th.
25th.
Paul, can you put something out about that, please?
Yeah. Yep. I'll send something out.
Yeah.
Would
I'll bring my mini sumo.
Take it out with a sumo.
Yeah, it doesn't seem like Ross has any issues, buying these high-end, robot.
Yeah, but by the sounds of it, though, Ross mentioned that they're not selling, but they're sidestepping from lawnmowers to warehouse humanoids, which is kind of the plan for them to moving forward. So, wheel-based humanoids, and I just picture like Johnny Five, just short circuit.
That was such a great movie.
It was. It really was. It was not aged well, but it's a good movie.
Well, I know I'm late to the meeting, and I didn't get in the queue, but I do have an announcement of sorts. We, four of us, that being Paul Urbanus, Vlad, my neighbor Rich Sands, and myself, have held a kickoff meeting today for the Robomow, for Robomow automation. So these are the robots that Sensori was selling for $100, and quite a few of us bought more than one, and Rich and I pulled it apart. So if you guys are interested, I can walk you through, show you like what it's like under the hood.
I haven't gone and looked, but I saw those show up on Facebook Marketplace. I haven't gone to look here recently. I don't know if they got any more of those left or not.
I believe they've sold all of the Robomow 612Ps, which was what they had about 80 of, and we took two of the it's like co-branded
Husqvarna's? Husqvarna?
Yeah, we took two of them to the dump on Saturday, which was sad to see, but that's where they went.
No use for parts?
No, they were pretty bad.
We held a meeting, and we had like a real high tech. We even had like a whiteboard on an easel, and oops, I'm about to lose my star. Sorry about all the giddiness there.
Wow, you used actual pigment.
Wow.
So yeah, we like made like lists of actions, and it was like a 4-hour meeting to like outline the scope and directions of a project to make these Robomows mow autonomously on RTK, using RTK GPS or some similar, that'll work for 3 out of the 4 of us. One of the guys has got like a lot of tree coverage on his property, so we're going to have to do something different for him, and I'm not sure what that is yet, but we were mapping out like who's available for how long, how much time they have, and the principles of the project. So we decided it's going to be a so its name is Mowberry, sort of a play on Mayberry RSD, which is apparently an Andy Griffiths TV show. I don't know it, but anyway, we sort of all liked Mowberry, so anyway, Mowberry is what it is. Going to be so we decided to license it under Apache 2, and we're going to use the DPRG's Discord for project communication about it, and use a Google Drive. So we'll create a mowberry@gmail.com account and get a Google Drive for it, and put all our working docs up there, and We're going to set it up to run on Docker. It's going to be Linorobot based because that provides just so much turnkey simulation and physical robot support. Let's see, it'll be on GitHub. So there's a fair bit to it. So looking at Rich and I pulled apart the robot, and let me just find my flashlight. There it is. So this is the robot without its cover on, obviously, and we mainly disassembled the back section. So inside, it's kind of cool. There's these. Oops, sorry, I'm trying to aim the camera, which is sort of backwards to me.
So is that 3 motors that actually cut the grass, or 2?
Two motors that cut the grass. Well, it's really hard to aim this thing because everything looks backwards. Yeah, you can see like there, there.
Yeah.
The 2 Mow motors. They're brushless DC. And then there are 2 DC motors, one there and one there. That are the drive motors. And Sensori produced a compatible version of that has a quadrature encoder mounted on the back of it. So we're going to slide out. You slide out the old motor, which is just does not have an encoder and at all actually, and slide in the new motor that's got quadrature encoders, and all the cable harnesses come back to this electronics box right here, where there are all these like connectors, kind of like sticking up in no circuit board. So the circuit board slips in the back there. We pulled out the circuit board, and so you've got the Mow motor, the drive motors come up from underneath. There's a radio, a GSM module right there for 2G communication, except no one does 2G anymore, I guess.
Yeah.
G, I don't know, but anyway, we don't think we're going to use that. But somewhere we haven't disassembled the front part of the mower yet. But somewhere under there are the bumper switches, and we think that there's a so that's the power, the charging contacts on the base, and there's like an infrared docking system that sort of is buried in both in the dock and in the front part of the mower, in this like illuminated, like that's actually a window there that I'm highlighting.
Probably an IR filter.
Yeah, right.
Yeah.
So what else can I say about it?
What's the high level objective? To mow a yard or what?
Yeah, to autonomously mow a yard in straight lines, using RTK GPS or some comparable localization technology. So currently this is a a wire follow or wire bound mowing robot. You know, where you put a boundary wire around your yard, and then it bounces off the boundary wire the way a Roomba bounces off walls, and mows the lawn that way. And the objective is to turn it into really one of what today you see a lot of is robots that are RTK GPS based, and many of them are AI based as well. And yeah, make it mow the lawn.
What happened to the company that was making these? You said that it moved. Are they still doing mower robots, or?
So the company that was making these, so that's actually Sensori, who's going to come and show us their robot dog and maybe a humanoid.
Okay.
Has pivoted. They've licensed this apparently, or well, actually, so a slightly longer version is apparently this form factor, which they call leave behind, because you know you like leave the mower behind at the customer's site, was not accepted by lawn contractors as being viable. So they repackaged it into a push mower style, with like a handle, the electric motor, electric hand, and a handle that's also autonomous and can drive itself around and do large areas, but also a crew member can take it and push it around and like mow under bushes, or areas where it's not trained to go, I guess. So they've licensed that tech to someone, and they're pivoting to work on humanoids.
Okay.
So they invented a handle.
Well, yeah. So,
and an override. Stop.
Shortly after they did the wheel, invented the wheel. The new handle.
I actually used this thing today because, like, I plugged my other one in for the first time, and it went into setup mode. I had it on the base, and it was powered, and it was like getting me to set the time and all date and all that, and then it said, "Okay, ready to test the dock," and I was like, "Okay, go ahead," and it like backed out, and I was like sitting there right behind it as it was backing out, and I was like, hit the stop, and it stopped, and so it was pretty neat. So what sits inside this electronics enclosure, right here where all the connectors are, is this circuit board.
So are you trashing that and replacing it, or?
Yeah, we think we're going to trash this and replace it.
Yeah.
But it's got all the motor drivers on it for the brushless DC blade motors and the DC wheel drive motors, and battery charging, and the interface to the LCD. So there's an LCD here that sits on top of the electronics panel, and it's got the buttons to say go and let you set like different modes and configure the robot. There's also a Bluetooth interface and an app for it, which probably we're not sure where exactly that comes out. Yeah, so you probably see some stuff come out on some chatter on the Discord as we like liaise with with each other on getting this stuff going. But the we kind of like, we've got a pretty powerful team on it, as it turns out. I'd say a very powerful team. We're very fortunate to have so Paul Urbanus, who's is a hardware whiz. So he's like done umpteen circuit boards, reverse engineers, circuit boards. He's like a real PCB design and FPGA design king kind of guy. And my friend and neighbor Rich Sands is really a security guy, but he's a good systems guy, and so he's good at like the requirement side of things, user stories. Did you think of this kind of thing? I envision doing much of the Ross software, so envision basing it off of Linorobot, because Linorobot just brings so much to the table in terms of simulation and physical robot control, just prepackaged and just works out of the box.
So you're going to use Pi 5?
What?
A Pi 5 or something bigger?
Good question. The fourth member of our team is Vlad, who's a longtime DPRG member, and turns out he's a high-level software and AI guy. And we're like, AI? Well, and he was like real up on GEM and putting LLMs on Pis, and he says, "Oh, you'd want a Raspberry Pi 5 for that," and so, yeah, unclear which direction how that's exactly going to all work out, but that's a great direction to go for, like the user interface level, like you or I or Mark or Harold could say, mow my front lawn on Wednesdays, and then Harold could say, and in the best Texas style, do the back lawn on Saturdays. And AIs understand all that stuff. So
And I won't understand Harold.
Well, okay.
Accent's just a bit thick.
My East Texican will get in the way.
Anyway, you get the idea. There's probably a place for AIs up at the application layer, and the user interface layer, and the kind of like overall what mission control kind of layer. Then it appears that Ross has a plugin for nav2 that does coverage. So mow for coverage. Cover the whole area, and so it looks like you can use, like we'll be able to use nav2, and Linorobot has the kind of like bundles together simulation and the physical robot into a interchangeable entity. So yeah, it'd be interesting to see where it goes. So that's what we're getting up to.
Are you just going to do it kind of in sort of in support for that Mower platform, or could you like consider a homemade scooter wheel platform, brushless 3D motors, 4 of them, 4-wheel drive kind of thing?
You're talking about a skid steer mower.
Yeah, made with hoverboard motors.
Actually, that would fit right into the parameters of the project, because one of the key parameters is that one of the key parameters is to be Linorobot based, partly because, and this is not in service of advancing Linorobot, but just because I'm a maintainer on it, and it offers so much parameterization that for both the simulated robot and the physical robot, and
Okay.
and there are some things that I'd like it to have that it doesn't, like GPS, RTK GPS support, and which is integrated into nav2, but not in a there's a launch file for it kind of way, not integrated in that way into Linorobot. So there's some, Linorobot brings a lot. There's a few gaps here and there that I think it would do good for Linorobot to fill. But more than anything, it's just a very parameterized Ross robot system for differential drive or skid steer, which is what you're asking about, Ray.
Yeah.
Or holonomic robots. To date, only for indoor robots, but that will change when I add GPS support into it.
The scooter motors are, well, you probably know they're 3-phase brushless. Is there an issue supporting those, or?
So the Linorobot supports 4 motor driver styles out of the box. There's the 2 flavors of generic A and B and PWM pin. There's like two styles of that motor configuration, and there's a BTS 7960, I think it is, style of motor controller, and an electronic speed control style of motor. I imagine that your brushless DC motors probably use ESC style, it's like a PWM servo pulse style controller. And so that is one of the supported motor controller types.
Okay.
So that would fit right in.
Yeah. These aren't ESCs per se, but they're pretty much, you put in a PWM pulse and it makes the motor spin at a certain rate, certain velocity, I guess. But
okay, so we need to distinguish between PWM 0 to 100% for stop to full speed, and the ESC style servo, which is like speed control, which is 500 microseconds to 1.5 milliseconds, pulse width from 0 to 100% of speed.
Yeah.
Both of those are supported.
Okay. This is a single line for direction, and then another one for pulse width modulation. So I haven't seen if, I know it connects to the hall sensors, the 3 ABC hall sensors that the motors have. I was hoping I could use one driver to drive 2 motors, or one side, and then just hook up the hall sensors from one of the motors. So one would be more or less open loop, based on what the other one is doing, but the drive to the 2 motors would be the same. The A, B, and C phases, but I haven't tried that out yet. I don't know if that works. So
we should probably talk offline, because it's kind of like a dedicated conversation.
Okay.
About what exactly the Linorobot 2 hardware repo supports, the exact style of motor interface that it supports. But just to say, at a high level, it supports it assumes there's a motor driver, and the motor driver supports PWM in a couple of flavors, or ESC. Actually, PWM in really 3 flavors, because the BTS 7960, whatever it is a flavor of PWM. So say PWM in 3 flavors. You could always add to it, but that's more work. But I'm just saying, out of the box, supports 3 flavors of PWM motors plus ESC, which is a servo, 500 microseconds to 2 milliseconds. And so, and applying that to either differential drive or skid steer.
Yeah.
Or Mechanon, but who uses Mechanon? No one outdoors. So those are kind of the parameters that it works in. So it sounds like your mower could be pretty close to aligned with the parameters of the project.
Yeah. I don't know if anybody's else interested in that, but I've wanted to make a hoverboard mower for a while, so hopefully this summer.
Well, I've got a couple of questions. One is a low-level question. How many wheels are on your lawnmower? I see the 2 back ones. What else is there?
2 drive wheels and a caster.
A caster on the front. Okay. Now, I'm curious, what sensor complement do you believe you'll have to put on the robot, primarily from an obstacle avoidance and safety perspective?
Good question. Let me just bring up, hang on a second, let me just switch.
It's one thing to make it drive around and cut the grass and not go on the neighbor's yard, but what do you have to do about all the other things?
Toes, toes are important. So.
Yes, and the dog and the kid and the ball.
That's right. Yeah.
Just put a sign. Don't let your kid play in front of the lawnmower.
The curious cat.
You'll be the guy with the fence around the yard to keep the kid out.
Okay, so let me just share this window.
The curiosity kills the cat, so yeah.
I've seen these things on TV with the giant swinging blades. Don't they build a big metal cage to put them in?
Yeah, you'll only have to apologize once for killing the kid.
Okay, diagram.
Okay, so you're seeing the block diagram here.
Drive motor.
So this is what, so the heart of Linorobot is a robot computer, which we envision being an RPI 4 or 5. And Vlad wants to put an LLM in there. He's talking about Gem, and I don't know those what all that means too much. A cellular modem to allow access to an RTK to go server to feed corrections to the RTK GPS, and also to allow VPN access from a laptop in your house that's far away from where the mower physically is. So the question was about the sensor suite. So the Mower OEM has a front PCB, which we haven't exposed yet in our disassembly of it. So we don't really know much about it, but it comes back to the current main PCB via a 22-pin connector. And what has connected to it is collision sensors, that being the front bumper. Doesn't have a rear bumper, so just only the front bumper, I believe left and right. There's a stop bar, that hand stop switch, caster lift. There's a blade housing that kind of surrounds the the mower blade deck, and it probably has lift sensors. I don't know. And then we believe there are dock approach sensors, probably IR. So that's really the sensor suite. So, to talk to, can it run over your kid's rag doll that they left lying on the lawn?
No
I
problem.
believe the answer will be absolutely yes. Just like any robotic lawnmower from today's technology would. And could it run over a person? Well, they would. That's tough.
Have
That
to
would
be
be
very
difficult.
small.
Yeah, small stuff that would be like comparable to bumps in the lawn and branches that might have fallen on the lawn, small branches that might have fallen on the lawn, it might go over.
Don't leave your babies on the lawn.
Babies are
Isn't that a country song? Mama, don't you let your babies on.
babies are taller than the bumper height sensing. So
Not if they're low. What if they're on their backs?
yeah, I mean, you saw what the bumper.
Arms flailing out to the sides,
It's like 2
The
inches.
very little ones.
Baby
It's
rabbits.
like, it's
Might
like
even look like a baby seal from below. I don't know.
there's no baby that's 2 inches tall, which is what it would take to fit under the mow deck.
A rabbit.
To get
Oh,
under
they're
the
lying
mow deck,
down and they put their arms out.
yeah.
They're under.
If you've got a 2 inch high baby, then you've got a deformed baby. I'm sorry, Harold.
Yeah, I'm sorry, lady. Your baby was bleeding like that before he got on my lawn.
So anyway, the RPi talks over serial to an ESP32 or a Pico, running micro Ross, and that runs the sensor PCB, the IMU, and the brushless DC motors for the blades, and the DC motor controller for the drive motors.
I love how your motors are databases,
What?
data stores. Diagram wise, it's just a stupid joke.
No.
Don't worry about it.
The container is a database store.
Yeah, exactly.
I'm sorry, I'm not following.
The symbol you're using for
Your
the motor.
symbolism, yeah.
The symbol you're using is commonly used as a data store.
Oh, this thing?
Diagrams, yes.
It's like a motor.
Yeah. Yes. Hey, I just pulled it out. It's a cylinder, man.
It looks
That's what
like-
motors look like. You know that.
Most motor-like thing there, yeah.
It's a motor-like thing. Yeah.
I'm
Anyway.
impressed. I hate Dryo. It always does things wrong for me.
So yeah, that's what we envision. And
So did you look at Openmow and decide that wasn't the way you wanted to go?
what is Openmow?
Oh.
Oh,
Uh-oh.
you don't know about Openmow.
No, I don't know about Openmow.
It's a very active project that it's all about RTK robots and low-level microcontrollers, so Arduinos and stuff like that. It's got a huge user base. They got a Discord. They're very active.
Openmow, M-O-W.
Uh-huh. But it's not Roz.
Open Mower,
Yeah.
maybe? Openmower.de?
It's a German guy.
Oh, I'm very familiar with this project.
Okay.
And yeah, the guy's name is his Discord is CES is his handle on Discord, and yes, I am very familiar with that. And yeah, X-Tech is his kind of like the company, or I'm not sure if it's a company or an LLC or whatever it is. Yes, so
There are Roz ports of it too.
Yeah. I stumbled across that several years ago, and his approach is I would say pretty much the same as ours. The difference is that he and his team focus on small European style mowers that are like 12, 15, maybe 18-inch cut width at the max. And they've done a custom board for that you replace a particular mower with. So they've got like one
project has branched out to more platforms.
Okay.
There's a lot of extra work on that. I don't know if it's in the main line of work or it's just people adapting it, but I see a lot of activity. I haven't I'm not trying to advocate for it because I haven't evaluated directly myself.
Yeah.
But I was just wondering what your thinking was if you wanted to go preference for RAWs or whatever.
Yeah, so they're a RAWs-based system, and one of the like unique and interesting things about it is their path planning for mowing is based on tooling path planning for a
CNC.
Yeah.
Yeah.
Yeah, and so they've got a good ecosystem, and you know I'm not gonna slap them. I mean, they do good stuff. I felt that the size of the motor drivers that they used. So they built a singular circuit board that has the motor drivers on them for brushless DC for the blades, and I think it might be brushless DC for the drive motors as well. I'm not sure on that though. Is oriented towards replacing a single kind of replacing into a single kind of mower. I feel like we're a little more loose than that in a sense, in that I envision that we could put just buy an AliExpress dual DC motor driver for the drive motors and a AliExpress BLDC motor for the blade motors, and not care too much about the details of the platform that it's supposed to fit in.
Sure.
So I thought about that, and basically what turned me off was that they focus on small mowers with like 12 to 15-inch kind of cut widths. And okay, I didn't know they were expanding their the number of platforms that they support, but it's essentially replacing. Yeah, I've got nothing bad to say about them, but we're going in a different direction.
Okay, cool. I'm just waiting for the robot that can mow my lawn and fetch me a beer.
Yeah.
Well, I guess, Europeans, everything is smaller. So, maybe they're just used to using smaller mowers, 18-inch or 15-inch or,
I'm not going to touch that with a 10-foot barge pole, Ray.
Dude, that's so easy. That's something about she said or something. I don't know, but that's all I'm going to say.
Kareem, if you can get a robot to fetch you a beer and do it well, you don't care about what
I couldn't let it go. I tried to let it go.
Yeah, so we had like a 4-hour meeting over at my place today, and we worked out a lot of stuff. Had good alignment on a lot of like how we should do things, and Google Drive for working docs, and what you called LLM, Google has an LLM that will inspect your docs and let you query them. LM, I've forgotten its name. Anyway, good alignment on, and so we're like any project, we're dealing with resource constraints. How much time do people really have to spend on this stuff, and how much do we want to reuse of the mower? We're all in alignment about trying to reuse as much of the mechanics and motors and sensors as we can, but replacing the electronics and the software and firmware.
Yeah, I was going to say, if Vlad's working on the LLM, I don't think you have anything to worry about, Harold. He's got a pretty strong accent. If it can interpret him, he can probably handle you.
Yeah, might even understand Harold.
Yeah, might even understand Harold.
Yeah, that would be amazing. Yeah, what is it? I had a clip that I clipped and just sent up a little bit ago. Just because nobody understands you does not mean you're an artist. I'm just saying. I'm a perfect example of that.
Yeah, so that's that.
Sounds like a great project.
It does. It really does.
We'll have the best looking lawns in Texas.
I think you got a great team that can contribute things in different variety of different areas. So I'm excited, and so we still got more reverse engineering to do on the existing mower to find out what's under that bumper and how we can access it and take advantage of it.
Do you have the same problem with your lawns that we do up here in July, where they turn brown and crunchy, and the only thing that grows are the weeds?
Later in the summer, yeah. At least for me.
August maybe, but yeah.
I don't water, so.
Yeah, it depends if you water or not. Yeah.
Well, thanks for the update, Paul. That was good. Does anyone have anything else to bring up? Well, I guess that's the end of the meeting. With some good updates, guys. We will catch you next Tuesday.
Sounds good.
All right.
Great.
Thank you.
All right, guys.
Yep. Bye.
See you guys.